let's solve the derivative of some explicit functions involving arbitrary bases of exponential functions. So in this first one we have 9 to the x. Now for 9 to the x, the way we want to rewrite this is we want to say that function is e to the natural log of 9 times x. E to the natural log of 9 times x. That way, when we take the derivative, we say f prime is equal to e to the natural log of 9 times x times, so e to the something, the derivative is e to the something times the derivative of that argument. But this is just a constant times x, so it's this constant. But we know that this right here is 9 to the x. So we have natural log of 9 times 9 to the x. So remember, that's our general rule, is that if this was 6 to the x, it would be natural log of 6 times 6 to the x. That's the general rule for arbitrary exponential functions. Now this one we have y is equal to 3 to the negative 2x. Now we don't just have 3 to the x, we have 3 to the negative 2x. And there's two ways to solve this. If I'm being clever about it, what I would do is, instead of writing 3 to the negative 2x, what I would do is I would say that's 3 to the negative 2 to the x. Well, 3 to the negative 2 is 1 over 3 squared to the x, which is 1 over 9 to the x. And the reason why I would do it like that is that then I can follow directly. I can say, well then y prime is natural log of 1/9 times 1/9 to the x. And I know that 1/9 to the x, I know that 1/9 to the x is 3 to the negative 2x. So that's one way to do it. And then this is actually negative natural log of 9 times 3 to the negative 2x. So that's one way to do it. But the way that they want you to do it, at least the way I'm thinking they want you to do it, is by a chain rule. So instead of 3 to the negative 2x, you write that as 3 to the x to the negative 2. And we know that 3 to the x is e to the natural log of 3 times x to the negative 2. So then you say e to the negative 2 natural log 3 of x. So that's all y. So then y prime is e to the negative 2 natural log 3 of x times the derivative of this argument, and this is just a constant, so it's negative 2 natural log 3. So you end up with negative 2 natural log 3 times, because this right here is just our original, you end up with that. And then you might say, well, how is that equal to this? Well, if you bring up that 2, you leave the negative alone, and you bring that 2 up, you have natural log of 3 squared, which is this. So my guess is that's how they want you to do it. But don't be afraid to be clever. Exploit those rules to make your life easier. Now, if I have this function, g of x is equal to x times 5 to the x. To take its derivative, I'm going to need to use a product rule. So I'm going to say g prime of x is the derivative of the first one, hold the second one constant, plus the first one constant, take the derivative of the second. We know the derivative of x is just 1. And the derivative of 5 to the x is natural log of 5 times 5 to the x. So since 5 to the x is common to both of these, what I would do is I would write it as 1 plus x natural log 5 times 5 to the x. If it's me, that's how I write it. But you can You can probably leave it like this if you're trying to put it into like a computer system or something like that. And finally, we have h of t is 2 to the 9t over t. So for this one, we're going to do a very similar process, but we're going to use the quotient rule. Now again, if it's me, I would take 2 to the 9t and rewrite it as 512 to the t. So that's my personal opinion. And actually in this problem I'm going to do it that way. So I'm going to say this is 512 to the t over t. So let's do a quotient rule. Quotient rule says low times the derivative of high minus high times derivative of low over low squared. So the derivative of 512 to the t, so that's t is there, and then that's natural log of 512 times 512 to the t minus 512 to the t, and then the derivative of t with respect to t is just 1, and that's all over t squared. So what I notice is that 512 to the t is common to both terms. So I would take that out as 512 to the t. So that's t natural log 512 minus 1 all over t squared. And that, that's just the simple way to do it.